Okay, so in this one, I'm going to walk you guys through how to find the inverse of a 3 by 3 matrix using a very simple example, a very linear based one. Because the whole purpose is to really get down the formulas and know the steps inside out. Okay, so what do we need to do? So I need you guys to write a list of steps, okay? And this is where we're going to go. So the first step is to firstly find the determinant of m, which is, thank God, very easy in this example. We're going to use this towards, this is going to be one of the final steps. The second step is to find the transpose. So we're going to call this m to power t. The first step is going to be called the agitate matrix. So this is the node as A agitate and then M, ADJM. And this is linked to something known as the matrix of cofactors and so. And on the final step would be the actual inverse. And this is going to be a combination of the very first step and times the agitate matrix, and this will give us one of these three hopeful matrix. So let's have a go. So let's work out firstly the determinant. Okay, so this is, if you don't know how to do any of the steps, I've got videos on each of these, and hopefully you can have a look. So I'm going to do the first one, the determinant down here. So the determinant, how do we calculate it? Well, you can think of it as this. So the way I do this is I would rewrite this 3 by 3 matrix with 2 additional columns. So let's write here, yeah. So I'll make a little arrow there. So it'll be 2 0 0 and then 2 0 2 3 0 0 0 1, and then copy the first 2 columns. So 2 0 0 0 3 0. Now all you need to do is literally find the determinant by multiplying the diagonals. So what I'm going to do is firstly highlight this. So firstly, do all the possible diagonals you can from one corner to the other, and all of these in the circle will be the ones you're going to multiply inside, and then you're going to sum them up. For example, 2 times 3 times 1 will give us the value of 6. All these zeros multiplied to give us 0, and of course these ones are also 0. Next, we're going to subtract the other corner, so the other diagonal. So I'm going to change the color to say green, and guys, make sure you do the same thing. So make sure you correctly identify the diagonals, yeah. And the last one is these 3. So you can see all of these have 0, so for sure they're all going to be solutions of zeros. That means the final solution is going to be, thankfully, 6. So we know the first step, the determinant, is 6. Now what is the next step here? To find the transpose. Well, the transpose is dead easy, guys. The idea is to literally flip the rows and it becomes a column. So let's call this empty. So we have the matrix. This row now becomes 2 0 0. The next value, I'm going to change the color of the pen. So do this as a highlighter. So 0 3 0 goes downwards, 0 3 0. And the final one, 0 0 1, well, you got it. But I'll just do it anyway, would be 0 0 1. All right, cool. That's easy. Now, the agitate matrix. So this one is the very lengthy process where we have to find so many determinants. And this one deserves its own video. So the key idea is that we need to replace each of these 9 figures with the determinants of those that are not in its horizontal and vertical line. For example, if we're going to replace this 2, we need to find the determinant of these 4 figures because it's not in the horizontal vertical line. So there's a lot of 2 by 2 determinants. So let's have a go, yeah? Let's think of it like this. So let's call this let's just call this for now m prime, yeah? Type of m. What's it going to be before we get to the agitate? So replacing 2, we need to find the determinant of 3 of this little 2 by 2 matrix, which consists of 3 0 1 0. So the idea is to multiply diagonals of 3 times 1 minus this one. This will just give us a 3. Next one here, we need to look at these 2 figures, 2 zeros and 2 1s. Because you've got zeros in each corner, the determinant will be 0. Now you look at this value, and now you got this 2 by 2 matrix. So you got 0 times 0 minus 3 times 0, which is 0. Again over here, so now we look at this value. So now we're going to look at these 2 zeros and 0 1. So this will give you a 0. So basically you're going to end up with a bunch of zeros. I can already see where the zeros are coming. Now for this middle figure, we need to use 2 0 2, the first 2 is the last 0, this 0 and this 1. So 2 times 1 is 2, minus 0 is 2. And this one here, this corner, what's it going to be? It's going to be, we're going to need to replace the 1. So the 1's going to be these 4 figures with 2 3 0 0. So 2 times 3 is 6, minus 0 is 6. Now, what do we do here? So now we need to find the agitate. Okay, now we need to find the agitate matrix. So now we got this m prime, thank God. So all we do now is multiply m prime with something known as the matrix of cofactors. So it looks a bit like this: plus, minus, plus, minus, plus, minus, plus, minus, plus. So this is known as the diamond of negatives. And all you have to do literally is replace. We don't literally multiply. You just replace. You just invert every sign here according to this technique. So when you got positive, you keep the signs of its position. If you got negative, you flip the signs. For example, you got 4 negatives here in the diamond position, meaning these 4 figures will have to flip to negatives. Or no, they'll just flip signs. So if they're already negative, it'll be positive. Because there was 0 as well, 0 times a negative will still be 0. So actually the agitate is actually itself. So the agitate matrix in the end will end up being the same thing. So 3, 0, 0, 0, 2, 0, 0, 0, 6. Again, guys, this is just an easy walkthrough, so you guys don't get it doesn't get too complicated with all the hard numbers. I just wanted a quick, simple video for you guys. Now, finally, the final step is to do the my God, the inverse of m, and that all is simply multiplying your agitate with the 1 over the determinant of m, which is the very first step we took in the beginning. And thank God that's easy. So all we do now, so we can say finally that the m inverse is going to be 1 over the determinant, which was 6 times matrix of cofactors, or agitate matrix, sorry. And then multiply everything by a 6. Everything, all the zeros stay the same, but the 3, 2, and 6 become 3 over 6, which is half, third, and 1, and zeros all around. And that's it, guys. And this should be part 2.